Hey everyone, we're going to identify and graph the polar equation r equals 1 minus 2 sine of theta. So for identification purposes, this is a limacon with an inner loop, and I'm going to show you the form for that in a few moments. Right now, let's go ahead and test for symmetry so we can graph this. And we're going to check first for symmetry with respect to the polar axis by replacing our theta with negative theta. So we're just going to write r equals 1 minus 2 sine of negative theta. Since sine is an odd function, this negative can be brought out here, and we're going to get 1 plus 2 sine of theta, which does not equal 1 minus 2 sine of theta. Since our equations aren't equivalent, then this test fails. So it's not symmetric to the polar axis. Let's see if it's symmetric to the line theta equals pi divided by 2, which is the y-axis. So let's go ahead and do this test is replacing theta with pi minus theta. So we're going to have r equals 1 minus 2 sine of pi minus theta. Now this is your sum and difference formula with this format here, so let's expand that. I'm going to write it here. This is going to equal 1 minus 2, and then we're going to have sine of pi times cosine of theta minus cosine of pi times sine of theta. Sine of pi is 0, so this knocks out. Cosine of pi is negative 1. So you have two negatives, which make it a positive. So this is going to give me 1 minus 2 sine of theta, which equals our original equation. So this test passes. So our graph is going to be symmetric with respect to the line theta equals pi divided by 2. And last test is the respect to the pole. That means you just substitute your r with negative r right here, and that's going to give you 1 minus 2 sine of theta. Clearly these do not equal, so it's not symmetric to the pole. All right, the only time this will be symmetric to the pole is if you have this square, if r is square. So this is why it's a limacon with an inner loop. That's because my a equals 1 and my b equals 2. And since my b is greater than my a, or 2 is greater than 1, that means it's a limacon with an inner loop. If it was reversed, it would be without an inner loop. If it was the same, like if it was 2 equals 2, then it would be a cardioid. So basically, it's has this inner loop thing going on, and they're a little harder to graph. So since we did our test for symmetry, we can choose our theta it's symmetric with theta equals pi divided by 2. So we're going to assign values to theta from negative pi divided by 2 and pi divided by 2. So let's just assign values there and then use symmetry to complete the graph. So we're going to write theta and start at negative pi divided by 2. And then write negative pi divided by 3, negative pi divided by 6, 0, pi divided by 6, pi divided by 3, and then pi divided by 2. All right, my r value is what we're looking for, and our r equals 1 minus 2 sine of theta. Substituting in my values for theta, I'm going to get r equals 3 for this one. At negative pi divided by 3, we're going to get 1 plus square root of 3, which is approximately 2.7. At negative pi divided by 6, we're going to get 2 At 0, we're going to get 1. At pi divided by 6, we're at 0. At pi divided by 3, we're going to get 1 minus square root of 3, which is approximately negative 0.7. And at pi divided by 2, we're at negative 1. So let's start the graphing process. So at negative pi divided by 2, we're at 3. So go out 3. 1, 2, 3. At negative pi divided by 3, we're at almost 3, not quite. 1, 1, 2, 3. So go in a little bit. At negative pi divided by 6, we're at 2. All right. At 0, we're at 1. At pi divided by 6, we're at 0. So let's see how this is going so far. So it's looking like this. All right, and then at pi divided by 3, it's at negative 0.7. So at this line here, we have to go the other way, and that's going to be close to 1, but not quite. And at pi divided by 2, it's negative 1. So there we go there. All right, now let's work the other way. So now that we did this, let's look at 2 pi divided by 3. We're just going to use symmetry and come back around. So you're coming back around here, and then at 0, we're going to be at 1. So it comes back to 1. And then we're just using symmetry to graph this. And this was almost at 3. So it's coming back around like this. There's your inner loop. So basically we started here, goes around, flips around this way, and goes this way. And there it is. Thank you. Have a nice day. Bye-bye.